solve a system of equations by matrix inversion. So when we have system of linear equations, for example, two linear equations, that means we have two unknown. We want to solve for x, y, and we can use the inverse, matrix inverse, to solve for it. So we do the example first, and then we go back to work on this type of question. Now you have to solve for x, y, z. On the same side of the x, y, z, it gives us a 3 by 3 matrix. On the right hand side of the equal sign, it gives us a 3 by 1 matrix. 3 by 1. So the idea of solving for x, y, z, as long as I can find the inverse of this matrix, so 1, 1, 0, 1, 2, 1, 2, 3, 2. So when I multiply the inverse of this matrix and do the same thing to the right hand side, I multiply the inverse of this one. Now here, location does matter. So when you have the inverse of this matrix, you put it in the front on the left hand side. When you multiply the same inverse matrix to the right hand side, it need to stay on the same spot, which means stay in the front. Otherwise, you will get a wrong solution. So here, order doesn't matter. Keep in mind. Now, once you multiply the inverse of the matrix to the right hand side, on the left hand side, these two, it will reduce, turn to the identity. And identity it means just 1. And then from there, you can solve for x by using the inverse of the matrix to multiply with the matrix B, if I give this as the name of B. So now, we need to create a matrix A with this one. So you have 1, 1, 0, 1, 2, 1, 2, 3, 2. You need to create a matrix A. You also need to create a matrix B, which is 20, 30, and 55. So this is 3 by 1. This is 3 by 3. I'm going to show you how to use the TI-84 to construct a matrix 3 by 3 matrix and a 3 by 1 matrix here. So first, you click on second, click on matrix here. Is the same key with your x power -1, and you can see the blue font there. It put a matrix. Before you operate the matrix, you need to create a matrix. So we call added. So you move the arrow right to the added, and the first matrix pop up is at matrix A. So you hit the enter key. Now you need to insert the size of the matrix you have. Matrix A, I have 3 by 3, so I input a 3. You click on 3, hit the enter key, click on 3, enter one more time. Now, the box here, you have to fill in the element of your matrix A. So I have the 1, 1, 0, so you click on 1, enter, 1, enter, 0, enter. And you do the same procedure for the rest of the element. Once you have the matrix complete, you need to click on you need to click on second, quit, and go back to the front page. Now we need to do the same procedure to create a matrix B. So click on second, matrix, move to the added, go down to the matrix B, hit the enter key. So you have to give the dimension is 3 by 1. So I input a 3, enter, 1, enter. And then you input the element 20, 30, and 55. When you complete the matrix B, same way, click on second, quit. Now, since the left hand side of the matrix here, These two tend to the identity, right? So we don't have to worry about these two. The thing we need to consider would be the right-hand side two. So we use the inverse of the matrix A to multiply matrix B. So we need to give a command to the calculator so that it will run it for you. So now, how do we do that? Click on second matrix. From here, you can see it highlight the names, right? And under the name, it highlights the matrix A. So you hit the enter key. Now you want to process the inverse of the matrix A. So the inverse key is on the same key with your matrix. So click on -1 with the power -1. You click on it. So this means you give the command to ask the calculate to run the matrix A inverse. After that, multiply with the matrix B. So click on second matrix. Same way, highlight the name. Now you click on down arrow key to highlight the matrix B and hit the enter key. So you will pull all the matrix B to the front page to multiply with the inverse of the matrix A, and then you hit the enter key one more time. So the result here, it shows us is the X, Y, Z. So X is 15, Y is 5, and the Z is 5. So with the calculate, everything will turn to so easy. When you have the 2, 3 by 3, 4 by 4, 5 by 5, as long as you know the concept, how to use the inverse of the matrix to rearrange your equation, and then you will solve for the unknown variable. Alright, so we look at this example. A company that manufactures medical equipment spends time on paperwork, manufacture, and the testing for each of the versions of a circuit board. The time spent on each and the total times available are given in the following table. So they have these 3 different categories, and it has a product A, B, C. And the hours available is 20, 30, and 55. So now they want to know what would be the number of the unit of the product they need to produce. So we can give this is A, this is B, this is C, right? So if you write down the equation, with the paperwork, we will have the A plus B. C is 0, there's no C. So you'll get the 20. This is the paper. So with the manufacturer, we have the product A is 1. So the same way you have the 1 is 1A plus 2B plus C is equal 30. With the testing, we have the 2A plus 3B plus 2C is equal 55. So now if you look at the left-hand side of the equation, we have A, B, C. So we have 3 unknown. We create a matrix A with a 3 by 3. So this will be the matrix A. We fill in the number. And all the number, they are the coefficient number of each term. So since there's no number here, I mean it's 1, 1, 0. On the second equation, we have the 1, 2, 1. On the third equation, we have the 2, 3, and the 2. And then you create a matrix B, which is 20, 30, and 55. So now, as here you can see, This is exactly the same question we just did earlier. Right? We have 1, 1, 0, 1, 2, 1, 2, 3, 2. X, Y, Z, that would be your ABC. It's the same meaning. And the right hand side has 20, 30, and 55. So when we solve it, we get ABC is 15. We have A is 15, Y is 5, and the Z is 5. Okay, so we just did this example, and you can treat this as ABC. That is okay. Or you want to keep the X, Y, Z. It doesn't matter as long as you know how to solve it. So now I'm going to show you the work from your Weber sign. Use the matrix inversion to solve the system of equation. So we have X, Y, Z. That means we have the 3 system of linear equations, right? So we need to create a matrix that multiply with the X, Y, Z that will equal the right hand side result of the matrix. So the right hand side is very easy to see, has 7, -1, -3. The left hand side 3 by 3 matrices, they are coming from the number of each term, the coefficient number of each term. So we fill in the box of the matrix number. So we have -2, +1, -3. Now we move on to second equation. We have 2, 3. There's no Z term, so we put a 0. The third equation, X is 1. There's no Y, we put a 0. And the Z term is just 1. So this is a 3 by 3. Now in order to solve for X, Y, Z, we need to get the inverse of this matrix A, right? So we need to multiply the matrix, the inverse of this matrix, and then multiply with this -2, 1, -3, 2, 3, 0, 1, 0, 1. And this is the same thing. You just need to find the inverse. And then these 2 will reduce. Once they reduce, you can find the X, Y, Z. And your right hand side, don't forget to multiply the inverse of this one. So now we need to create a matrix A and a matrix B. And then we pull out the matrix A, take the inverse to multiply with the matrix B. So we take out the calculator. So I click on second matrix. Move to the added. I'm going to use the matrix A. Now I'm going to change the size. This is 3 by 3, so it's the same. But the element I need to change it. I have -2, so I put a -2. 1, -3, 2, 3, 0, 1, 0, 1. And then I click on second quit. Do the same procedure, second matrix, move to the added, go down to the matrix B, hit the enter key. The matrix B, I have 3 by 1, right? And then we need to change the number. So I have the 7, -1, -3. So click on second quit. Now we need to pull out the matrix A and find getting the inverse, right? So do the same procedure here. Second matrix, pull out the matrix A, Now once you start to operate your matrix, don't go